Right, so here we need to find the second derivative. When you see the square there, you must know that means second derivative. So here determine d squared z over dx squared and then d squared z over dy squared. After we're done with that, we're also going to prove that d squared z over dx dy is equal to d squared z over dy dx, which is the last two there. Can you see that? We got 1, 2, 3, 4. So it's 1, 2, 3, and 4. 3 must always equal to 4. If 3 is not equal to 4, you made a mistake. Okay. Let's take the first example. So here we got z is equal to cos of 5y times sine 6x. Let's start with finding d squared z over dx squared. Right, so we got d squared z over dx squared. So you need to understand how to write this out properly. Okay, so d squared z over dx squared, what does it mean? It means you need to find d over dx of dz dx. Right, you can see if you multiply there, you get your square dx, dx is dx all squared. So check it by multiplying. So what do you need to do first? You need to do whatever's inside the bracket. That will be the first operation, which is to find dz dx. Then the second thing is to differentiate one more time. D over dx means differentiate dz over dx. So let's do the first part, which is dz dx. Right, so we need to differentiate cos of 5y times sine of 6x with respect to x. Okay, with respect to x, it's multiplication. Cos of 5y is being multiplied by sine of 6x. Do I need to use the product rule? Can I use the product rule? I can use the product rule, but do I need to use it? Is it necessary? It's not necessary because I'm differentiating with respect to x. So I will treat cos of 5y as k a constant. Okay. So if I wanted to differentiate k sine 6x, what will the derivative of k sine 6x be? All I'm going to do is differentiate sine 6x and multiply it by k. Right, so you imagine cos of 5y, or you treat cos of 5y as it is a constant. Okay, so that will be cos of 5y times the derivative of sine 6x. What is the derivative of sine 6x? It's going to be cos of 6x. Am I done there? Times the derivative of 6x, which is 6. Right, so if I simplify this, this will be just 6 cos 5y times cos 6x. So what did I do? I just found dz over dx. Can you see that? Now, d squared z over dx squared. So that means d over dx of what I just found now. So that will mean d over dx of dz dx. What was dz dx? It was 6 cos of 5y times cos of 6x. So it's clear, this is what we have, and we need to differentiate it with respect to x. Okay, so now we will treat 6 cos 5y as a constant because it's multiplication. You can see that. We can use the product rule, it will still work, but it's unnecessary. So all I'm going to do is differentiate cos of 6x and I'll multiply it here. So that's 6 cos 5y times the derivative of cos 6x, which is minus sine 6x. Am I done there? No. Times the derivative of 6x, which is 6. If I simplify there, that will be 6 times negative 1 times 6, which will be minus 36 of cos 5y sine 6x. Alright, so what did I do? I just found d squared z over dx squared. Now, let me find d squared z over dy squared. So d squared z over dy squared. Again, understand how to write this down properly, otherwise you'll make a mistake. So this means d over dy of dz dy. So what do we do first? Whatever's within brackets. Yes.
So the first part we must write what in the brackets is equal to.
Yes, yes. You see, if you check here, d squared z over dy squared, that will be d over dy times dz dy. If you check d times d, there will be d squared, dy times dy will be dy squared. But I think your question is, do you have to write this down? Okay, you do not have to write it down, but if you write it down, then there's a lesser possibility of you doing the wrong thing here. Okay, so it's best to write it down so you know what to do now. What you do first is within brackets. So let's find dz dy. So now I am differentiating with respect to y. That means I need to differentiate cos of 5y. So I will treat sine of 6x as a constant because it's multiplication. So that will be my k, a constant. Alright. So I'm going to differentiate cos of 5y. The derivative of cos of 5y will be minus sine of 5y times the derivative of 5y, which is 5, multiplied by k, your constant, which is sine 6x. Let's just simplify this. This will be minus 5 sine of 5y times sine of 6x. So what did I just do? I found dz over dy. So therefore, what I will do is I will substitute here. So that will be d over dy of dz dy. What was dz dy? I just found it, which is minus 5 sine 5y sine 6x. Now it's clear, it's impossible to make a mistake now. You are differentiating with respect to y, so you will treat sine of 6x as a constant. So now your sine 6x is treated as k, which is a constant. We are just differentiating your sine 5y. Can you see that? So that will be minus 5 times the derivative of sine 5y is what? Cos of 5y times the derivative of 5y is 5 multiplied by k, your constant, which is sine of 6x. Let's just simplify this. So you got your minus 5 times 5 there, which is minus 25 cos 5y sine 6x. Right, so what did we just work out now? We worked out the second derivative here and there. Now, let's deal with that number 3 and 4. So now you're going to see why it's important to write it down so you do not differentiate the wrong thing. Right, so now we need to prove that d squared z over dx dy. Prove that the left hand side here is equal to d squared z over dy dx, which is the right hand side. So now, you're given that question, let's write it down. So d squared z over, what is it there, dx dy. So this is the left hand side. So now, this is a question that you're given. How do you know what to do first, what to do second? Because you have dx and you have dy there. Can you see that? So you must not get confused here. So, what's on the left, you will write it as d over dx multiplied by dz dy, not the other way around. It's clear now. If you multiply, it's correct. You can see d times d there. D squared dx is in front, dy is behind it. You can see that. What do you do first? What's within the brackets? Okay. So now let's see what happens here. So we got d over dx of dz dy. But we just found dz dy now. What was dz dy? Where was dz dy? Dz dy was minus 5 sine 5y times sine 6x. Now, you wrote this down, so you know what to do now. You need to differentiate this with respect to x. It's clear now. So what will you do here? You will treat minus 5 sine 5y as a constant. Okay. So that will be minus 5 sine 5y times the derivative of sine 6x. What is the derivative of sine 6x? That's going to be cos of 6x times the derivative of 6x there, which is 6. Simplify there, minus 5 times 6, that will be minus 30 sine 5y cos of 6x. Now, let's take the right hand side. Right, so now check how is it written down. What must you do first? What must you do second? So this is going to equal to d over dy, because dy is written first here. Can you see that? Multiplied by dz over dx, because dx is written second. When you're reading, you read from left to right. So what's on the left is what you need to do first. But now it's clear. Once you got your brackets, dz dx is what you need to do first, but we already found dz dx. What was it? Where is my dz dx? Where is dz dx? dz dx is 6 cos 5y cos 6x. There's it here. dz dx. Alright, so that is 6 cos 5y cos 6x. Now, it's clear. What do we need to do here? We need to differentiate with respect to y. So you will treat x as a constant. That means you will treat cos of 6x as a constant. Because we are differentiating with respect to y. So what is the derivative of 6 cos of 5y? This is 6. The derivative of cos is what? Minus sine 5y times the derivative of 5y, which is 5, times your cos of 6x. Let's just simplify there. We got 6 times minus 1 times 5 there, which is minus 30 sine 5y cos 6x. What do you notice? Here's your left hand side and here's the right hand side. Alright, so therefore the left hand side is equal to the right hand side. And what you will notice, it works in all cases, for all examples. If you see that the left is not equal to the right and you tried this out, then you made a mistake. You have to go back and check where was the mistake. That's why it's important. We can copy this down and then we'll deal with the next one. Why? So let's find d squared z over dx squared first. So obviously we need to find dz over dx before finding the second derivative. Right, so the first derivative dz over dx. So how do we differentiate e to the power xy? It will be e to the power xy times the derivative of xy. The derivative of xy, but with respect to x, so you treat y as a constant. So the derivative of x here will just be 1 times y. Follow? Y is a constant. So now, second derivative, d squared z over dx squared. That means d over dx of what we just found. So d over dx of y e to the power xy. So here we are differentiating this with respect to x again. So we treat y as in this case a constant. So that will be y e to the power xy times the derivative of xy again with respect to x. So that will be 1 y. Okay, which is now equal to, we can simplify, that will be y squared e to the power xy. Now let's find dz dy. So dz dy, we go back. We need to differentiate e to the power xy with respect to y. So the derivative will be e to the power xy times the derivative of xy with respect to y. So you treat x as a constant. So this will be x times 1. Okay. Second derivative, d squared z over dy squared. Again, understand how to write it out so you don't make a mistake. So that's d over dy of dz dy. What was dz dy? We just found it, which was x e to the power xy. Now, we are differentiating x e to the power xy with respect to y. So the x here is treated as a constant, so there is no need for the product rule because x is a constant. So we are differentiating x e to the power xy. That's like k e to the power xy. So that will be x e to the power xy times the derivative of xy with respect to y. So with respect to y, you treat x as a constant, so that will be x times 1. So we just multiply that, that will be x squared e to the power xy. So now let's deal with the proof. So we already have half of the information to prove the left hand side equal to the right hand side. So let's deal with the left hand side. Left hand side here, d squared z over dx dy. Be careful. Write this out properly. We read from left to right. So that will be d over dx of dz dy. So that will be d over dx. What was dz dy? Here is dz dy. We just found this one. Can you see that? So my dz dy was x e to the power xy. So now we treat this as u and the second term as v. So the product rule will be u v prime plus v u prime. So now, what is my u? U is the first term there, which is x v prime. The derivative of e to the power xy is going to be e to the power xy times the derivative of xy with respect to x. We treat y as a constant, so you're only differentiating x, which is going to be 1 times y. Okay, that? That will be u v prime plus v, which is e to the power xy times u prime. U was x, so u prime, the derivative of x is 1. So that's basically it. That will be xy e to the power xy plus e to the power xy. You can take out a common factor, but it's unnecessary to do that. So this is the left-hand side. So that was the left-hand side. Let's do the right-hand side. So the right-hand side here. So again, read this from left to right. So this will be d over dy of dz dx. So that will be d over dy. What was my dz dx? Dz dx was y e to the power xy. Okay, so we need to differentiate this with respect to y. Y appears in both terms. So you can see that. So use the product rule again. So my u is y, v is e to the power xy. So the product rule, that will be u v prime plus v u prime. Let's see what happens. So u here is y. So there is your y. V prime. V is e to the power xy. So v prime, the derivative of e to the power xy is e to the power xy times the derivative of xy with respect to y. So you treat x as a constant. So that will be x times the derivative of y, which is 1. Right. That's u v prime plus v. What was v? V was e to the power xy times u prime. U was y. U prime, the derivative of y with respect to y is 1. So this is equal to xy e to the power xy plus e to the power xy. Is it the same? Yes, it is. So therefore, the left-hand side is equal to the right-hand side. Now here is the difficult one. This one. Because you have to be able to simplify, otherwise it will not work. So here's the question. Prove. Same thing what we did here. Prove that the left-hand side is equal to the right-hand side. Let me give you a few minutes to try that out. One. You got z is equal to the tan with the negative 1. Does it mean exponent minus 1? No, be careful. In trigonometry, if you see the negative 1, it does not mean the exponent. Okay, it means inverse tan or arctan. So what are we dealing with here? We are dealing with z is equal to inverse tan of f of x from your formula sheets. Okay. So the derivative of inverse tan will be f prime x all over 1 plus f of x all squared. Okay. But what is f of x? F of x is, what is f of x in our example? F of x is y over x. Alright, so now, it depends now which one. Am I differentiating with respect to x or with respect to y? Let's take the left hand side then, okay? Because we won't know until we write it down. So the left hand side states we need to find d squared z dx. What is that? Sorry, that's dy dx. That's dy dx. So therefore that means d over dy of dz dx. So now it's clear. If I'm dealing with the left hand side, the first thing I need to do is I need to find dz dx. So therefore I need to differentiate y over x with respect to x. So now x is in the denominator of the fraction. Do I need to use a quotient rule? No. All I have to do is take x to the top. It becomes x to the power minus 1. I'm differentiating x, f prime. So remember, I'm differentiating with respect to x. I will treat y as k a constant. So it's y times minus 1, which is minus y. X minus 1 is minus 2. So that's clear. Okay, so now dz dx. So the formula is f prime x, which we just worked out now, minus y x to the power minus 2. Here's my f prime x, but it's actually f prime y. Okay. All divided by 1 plus, what is f of x? F of x is y over x all squared. Now, simplify as far as possible, otherwise you won't be able to prove this. So we got minus y over x squared, exponent law there, make my exponents positive. Right, so here now, we got 1 plus y over x all squared. It will be y squared over x squared. Okay, so now I got 1 plus y squared over x squared. I need to add this. Okay, I need to add it. How will I add this? I need to find an LCD, lowest common denominator. So this will be minus y over x squared. What will the LCD here be? It will be x squared. So I'm just going to use a shortcut method here of finding the LCD. So that will be x squared plus y squared all over x squared. What do I do next? I have a fraction divided by a fraction. So I copy down the top fraction, which is minus y over x squared. Inverts the bottom fraction and multiply, which is x squared over x squared plus y squared. And then, now you can see what happens here. You will end up with minus y over x squared plus y squared. So this is simplified. Okay. Minus y. So what do we need to do to this? We need to differentiate it with respect to y. But we will continue with that in the next lesson. Right.